Greetings from Munro Live once again, everyone. Our 4680 battery cell is now entirely disassembled. We're here to follow Antonio as he disassembles his machine, and we discovered a few intriguing things. What would you like to begin with, then? Let's begin with the actual disassembly. This kind of can is easiest to open by cutting around the rim using a pipe cutter. It was difficult because this piece of steel is fairly thick. We ultimately made it through the can, even though it took me a few passes to get the same path each time. We have an interesting episode today with none other than Sandy Munro, the master of demolition. We'll be delving deeply into Tesla's state-of-the-art battery innovations, including the groundbreaking 4680 batteries and a brand new creative Saku Pouch. We'll also look at the difficulties other manufacturers have using the 4680 form factor, how Tesla prevents galvanic corrosion in the Cybertruck, and potential changes to the Cybertruck in the future. We'll also talk about possible weight loss strategies and Tesla's optimized production procedures. Prepare yourself for a thorough examination of automotive technology in the future. To ensure you never miss an update, don't forget to hit the notification bell, like, and subscribe to Tesla Stock News. Now let's get started. Veteran in the area, Sandy Munro continues to delve deeply into the nuances of different manufacturers with an emphasis on Tesla in the dynamic world of automobile innovation. His years of experience have given him a deep understanding of how battery technology has evolved, with a focus on Tesla's 4680 battery and how it may affect upcoming car designs. It may be of interest to viewers because Munro recently discussed the possibilities of Tesla's batteries while discounting the idea of higher capacity via over-the-air updates. Instead, he emphasized the permanent nature of the batteries themselves and proposed that improvements may be made by fine-tuning electrical modules. The enthusiasm was increased when Saku's bag, which has the same voltage and power as its predecessors but is much slimmer and more affordable, was revealed by Munro as a new favorite in battery design. The absence of conventional components like copper and aluminum in this inventive battery bag signifies a substantial advancement in cutting production costs, possibly by 7 to 8%. This novel pouch design has advantages above financial savings. Because of its reduced profile, the vehicle's interior can be used more effectively, possibly providing more room for extra components or a larger battery. Removing copper and aluminum lowers material prices and streamlines the manufacturing process, which speeds up production and has a smaller environmental impact because fewer of these metals need to be mined and refined. It's evident that Munro is excited about this innovative design because it changes the way batteries are made and used in electric cars. This breakthrough may establish a new benchmark for the sector, inspiring other producers to investigate comparable cost-cutting and productivity-boosting strategies. This innovation also demonstrates how battery technology is always developing, stretching the envelope and opening the door to more inexpensive and environmentally friendly electric cars down the road. The Saku Pouch is an exciting breakthrough for manufacturers and consumers alike, since it is an example of the kind of forward-thinking engineering that propels the automotive industry ahead. Munro drew attention to one remarkable quality of these batteries: they have no risk of sparking or blowing up if split in half and yet hold the same voltage. This discovery, which marks a substantial improvement in battery efficiency and safety, has generated a great deal of enthusiasm. Turning our attention to Tesla's Cybertruck, a viewer posed a relevant query regarding how Tesla prevents galvanic corrosion between various metals, like aluminum and stainless steel. This kind of corrosion happens when two distinct metals come into touch with one another electrically when an electrolyte is present, causing the metals to deteriorate. According to Munro, Tesla uses a specific glue to stop this corrosion, which is essential to preserving the longevity and integrity of the car. There are two uses for this glue. First of all, it serves as an insulating link, keeping the dissimilar metals from coming into electrical contact with one another and perhaps causing corrosion. This process is comparable to those employed in aircraft, where insulating layers between various metals are created by applying compounds like iodine. Tesla makes sure that the Cybertruck's body is durable and free of corrosion by using such cutting-edge methods. Second, the remarkable strength and longevity of Tesla's adhesive are indicated by how difficult it is to remove. This feature is essential to the construction of vehicles because it guarantees that the adhesive bond will hold up in the face of a variety of strains and environmental conditions. This adhesive's longevity adds to the Cybertruck's overall structural integrity, protecting it against deterioration. Munro added that both mechanical fastening and adhesive bonding are used in the manufacturing of the Cybertruck. By adding another degree of protection, this combination makes sure that the body parts of the car are kept firmly in place and shielded against galvanic corrosion. Tesla's methodical approach to resolving this possible problem demonstrates its dedication to building durable, high-quality automobiles. By using such cutting-edge techniques, Tesla not only improves the Cybertruck's performance and longevity, but also establishes a standard for corrosion resistance in the auto industry. Tesla's commitment to engineering brilliance and innovation is demonstrated by this emphasis on cutting-edge materials and building methods, which guarantees that its cars will endure over time. In response to a viewer's inquiry regarding the difficulties other producers encounter while implementing Tesla's 4680 battery technology, Munro clarified the major technological obstacles at play. Tesla has been able to attain a higher yield and greater efficiency in the production of batteries because to their novel approach, especially their use of a dry cell technique, by doing away with the need for drying ovens and solvents, this procedure streamlines production and lowers expenses. Many other manufacturers, on the other hand, still depend on conventional wet procedures, which entail combining solvents and active ingredients to create a slurry that is subsequently coated onto electrodes. In addition to producing higher scrap rates, this process has a greater environmental effect due to longer production times and the need for sophisticated drying equipment and solvent fume management. Tesla's invention of the dry cell technique provides a significant advancement. Tesla has achieved a 30% reduction in the length of its battery production line by eliminating solvents from the process. This decreases their manufacturing operations' environmental impact dramatically by removing the need to handle and dispose of dangerous chemicals in addition to increasing efficiency. Munro noted that one significant barrier is the greater scrap rates that other manufacturers face. It is difficult to attain consistent quality in the wet process due to its complexity and precision requirements, which increases the percentage of defective goods. In contrast, the dry cell process used by Tesla results in more consistent and dependable batteries, which raises the production efficiency of the product as a whole. Additionally, there are secondary advantages to Tesla's efficient production process, like increased worker safety and lower operating expenses. A safer and more effective work environment is produced by the lack of dangerous vapors and the decreased requirement for intricate drying systems. In addition to increasing production capacity, this efficiency establishes Tesla as a pioneer in environmentally friendly manufacturing techniques. Munro's observations demonstrate how Tesla has distinguished itself from other manufacturers by making substantial technological strides in the production of batteries. Their capacity for innovation and process improvement highlights their competitive advantage in the electric car industry and opens the door for more economical, ecologically friendly, and productive battery technology. Tesla's dedication to leading the industry in performance and sustainability is demonstrated by this invention. Sandy Munro goes into additional detail about the subtleties of Tesla's manufacturing procedures, emphasizing how technological developments have made assembly line operations more efficient. Notably, Tesla's choice to eliminate the use of sticking agents and electrolytes in the creation of batteries has resulted in a much shorter production line, improving worker safety and efficiency. Munro predicts a number of minor but significant changes to the Cybertruck's future that will improve its longevity and performance without changing its recognizable appearance. It is anticipated that these technological changes will be made in a way that is imperceptible to the typical consumer, protecting the Cybertruck's well-known usefulness and style. Munro talked in particular about the panels on the Cybertruck being stable. It has been suggested by some that thinning these panels could lighten the car and increase performance and efficiency. However, because of the risks involved, Munro cautions against using this strategy. An example, at high speeds, thinner panels may result in higher vibrations or structural weaknesses that jeopardize the overall integrity and safety of the vehicle. For a number of reasons, it is imperative that the panels maintain their current thickness. First and foremost, it makes sure the Cybertruck is sturdy and resilient to all the strains it faces while operating, such as fast driving and off-road situations. Smaller panels may resonate or vibrate at specific frequencies, which over time may cause fatigue and noise. The Cybertruck's unique look, which blends toughness with a futuristic elegance, is also a result of the present panel design. Any modifications to the thickness could lessen the vehicle's distinctive market appeal by changing its visual impact. Munro also pointed out that Tesla is probably going to concentrate on interior changes that improve efficiency and dependability without affecting the vehicle's external design. These might involve upgrades to the Cybertruck's electronic systems, suspension, or engine. Tesla can keep improving the Cybertruck's features without sacrificing the aspects of its appearance that have made it so well-liked by concentrating on these areas. Moreover, Munro's observations imply that Tesla gives practicality and user experience equal weight with innovation while designing cars. With every new generation of the Cybertruck, Tesla guarantees a smooth transition by avoiding overt modifications that could alienate or mislead customers, building a sense of continuity and confidence among its user base. Regarding more extensive approaches to weight reduction, Munro surmises that Tesla may investigate thinner-walled castings or modifications to the suspension system, but he emphasizes the necessity of extensive off-road testing to verify these possible adjustments. We delved into Sandy Munro's revolutionary insights, a titan of automotive disassembly analysis, in today's deep dive. We examined developments in battery technology, paying particular attention to Tesla's 468 batteries and Saku's creative new pouch. We talked about the difficulties other manufacturers have using the 4680 form factor, how Tesla prevents galvanic corrosion in the Cybertruck, and possible modifications to the Cybertruck in the future. We also talked about how Tesla has distinguished itself through its efficient production methods and made some educated guesses about possible ways to reduce weight. We've covered a lot of territory, from the nuances of battery safety and efficiency to the robustness of the Cybertruck's design. What do you think about these developments? What impact do you believe they'll have on how electric cars develop going forward? Do you think the automobile sector has any more room for innovation? We would adore to hear your opinions. Please leave a remark below, hit the like button if you thought this video was educational, and subscribe to Tesla Stock News to receive future updates on the newest developments in Tesla technology and business insights. We hope to see you in the future episode, so remain tuned and intrigued.